Is Gemma 4 the best local LM for a budget dual GPU setup? In my last video I combined a used $200 Intel Arc A770 with my older 16GB AMD RX 6800, 32GB of combined VRAM running Qwen 3.5 surprisingly well. This time, does Gemma 4 do even better? You also had a lot of questions about the dual GPU setup itself, and yes, I even dusted off this ancient GTX 960 with just 4GB of VRAM to answer one of them. What happened there? At the end of the video. First the benchmarks, then your questions. One quick note. Qwen 3.6 is out, but it's optimized for agentic workflows, coding agents, tool use. For general purpose inference, Qwen 3.5 is still the reference, and that's what I'm comparing against today. LM Studio on the left, updated to version 04.12. That's important for Gemma 4 template support. Windows Task Manager on the right. The CPU already shows some base load. That's OBS recording in CPU mode, keeping the GPU readings clean. Two GPUs, AMD Radeon RX 6800 with 16GB, 1.6 to 1.8 GB of base load from two connected monitors. And the star of this setup, the budget Intel Arc A770, also 16GB currently empty. Combined 32GB of VRAM. BIOS settings, rebar, the flash attention quirk on the A770, all covered in the previous video, linked in the description. Quick orientation. Gemma 4 is Google's latest open model family, released April 2026, Apache 2.0, fully free for commercial use. Number 3 of the Arena AI leaderboard among open models. Two sizes matter here. The 31B dense, all 31 billion parameters active on every forward pass. Maximum quality, slower throughput. And the 26B, mixture of experts, MOE, where only around 3.8 billion of the 26 billion parameters active per token during inference. You're paying the full memory cost to store all the weights, but only a fraction does actual work per token. That's why MOE models run so much faster than their size suggests. Both need to fit in VRAM entirely to run at full speed. That's exactly where 32 combined gigabytes becomes relevant. Solo reference first, A770 only, RX 6800 off. Runtime Vulkan. Model 26B MOE at UD IQ3S around 13.5 GB. GPU offload maximum. Flash attention off. Without this, the A770 produces corrupted output towards the end of longer responses. No performance penalty on my system. 35 tokens per second. In the last video, the A770 hit 50 tokens per second on a similarly sized Qwen 3.5 MOE. Both cards, Vulkan 31B dense at Q5KM around 24 GB. This doesn't fit on either card alone. You'll notice right away the VRAM split isn't even. The RX 6800 is carrying noticeably more than the A770. Not a bug? Explanation coming up next. 13 tokens per second. Comfortable reading speed. Qwen 3 32B dense in the last video, also 13 tokens per second at a similar file size. The memory bandwidth is the ceiling here, the model family doesn't change that. Output, benchmark prompt answered correctly and completely. Highest quality quantization that fits in our combined VRAM, 26B MOE at Q6KXL, 23.8 GB. The Q8 variant at 28 GB was slightly too large. The reason connects directly to what I'll explain next. 44 tokens per second. Qwen 3.5 35B MOE hit 50 in the last video at a similar file size. Close, and this is running a higher quantization quality. Output correct and complete. Gemma 4's responses felt slightly more concise than Qwen 3.5, different style, not worse quality. You've seen the asymmetry throughput. The RX 6800 consistently carrying 2 to 4 GB more than the A770. Here's why. Gemma 4 uses a hybrid attention design, two different types of attention layers within the same model with different internal memory footprints. When LM Studio splits the model across two GPUs, it divides by layer count, not by how much memory each layer actually needs. The heavier layers end up unevenly distributed and some of that overhead lands on GPU 1, the RX 6800. One important thing, the KV cache, the stored conversation history, still distributes evenly across both GPUs. The asymmetry is purely from the model weights themselves, not from the context you're building up. This is a known open issue in llama.cpp. A fix to make the split proportional to actual memory weight rather than layer count is in discussion, but hasn't shipped yet. And it's not just Gemma 4. I tested Qwen 3.5 35B, the model from last video, and saw the same 4 GB asymmetry. Qwen 3 32B split perfectly evenly because Qwen 3 used a single consistent attention design throughout. Qwen 3.5 switched to a mixed architecture with two different layer types, same root cause, different model family. Practical takeaway: with hybrid architecture models like Gemma 4 or Qwen 3.5 MOE, your effective combined capacity is a few gigabytes lower than the raw number suggests. If you want the cleanest symmetric split today, Qwen 3 is still your most predictable option. Now why I was holding the GTX 960 at the start of the video. Several of you asked in the comments whether adding any NVIDIA GPU to a mixed setup unlocks the priority order memory strategy in LM Studio. Priority order is significantly smarter than split evenly. It accounts for different VRAM sizes, different base loads and distributes the model accordingly. For a setup like mine where the RX 6800 always starts with less free VRAM due to the monitors, that would actually matter. So I installed the GTX 960, 4 GB completely useless for inference, but it's NVIDIA. With Vulkan selected and both the A770 and the GTX 960 active, still split evenly only. Tried restarting, adjusting cache settings, different combinations, no change. The result: priority order doesn't unlock in a mixed vendor Vulkan setup, regardless of whether an NVIDIA card is present. CUDA appeared as a runtime option after installing the NVIDIA drivers, but CUDA doesn't support the Arc A770, so that's not usable here either. According to LM Studio's documentation, priority order is available for NVIDIA multi-GPU setups running CUDA. Mixed vendor Vulkan is a different category entirely. So split evenly for now. The GTX 960 goes back in the drawer. Worth testing? Now we know. Someone asked, how far can you push context on 32 combined gigabytes? I tested Qwen 3.59B at Q4KM, 7 GB native context window of 262,000 tokens. At 262K context, total VRAM usage across both GPUs came around 21 GB. About 12 GB of that was KV cache, the conversation history. That's substantial, but it fits and speed stays around 40 tokens per second. On a single 16 GB card, 262K context at this model size isn't possible. On 32 combined gigabytes, it's comfortable. For larger or hybrid architecture models, the ceiling drops, and the primary GPU fills first. For Gemma 4 and Qwen 3.5 plan for effective capacity closer to 28 to 29 GB rather than the full 32. One more from the comments. Could I run Qwen 314B Q4KM through the dual setup and compare directly to the solo results? 30 tokens per second. A 770 solo in the last video, 25. RX 6800 Solo 40, Dual 30, right in the middle. This is expected. When a model fits comfortably on one card, splitting it across two via PCIe doesn't help. The GPUs need to synchronize every forward pass over the bus, and without a direct high-speed interconnect like NVLink, that overhead costs performance. The dual GPU setup is not a speed hack, it's a capacity hack. It lets you run models that don't fit on a single card. For those models, you've seen what it delivers. Gemma 4 on 32GB of mixed VRAM. The 31B dense at 13 tokens per second, matching Qwen 3 32B on a model that otherwise would run extremely slow. The 26B MOE at 44 tokens per second, close to Qwen 3.5's 50 at higher quantization quality. The VRAM asymmetry is real and explained. It affects any modern hybrid architecture model, and the tooling will catch up. Until then, plan your headroom accordingly, and Qwen 3 remains your cleanest option if you need a symmetric split. If this was useful, a like helps the channel, and if you haven't subscribed yet, that's what keeps these videos coming. And drop a comment. Are you running a multi-GPU setup, and which model are you actually using day to day? I'm curious what's working for people. Next up, the A770 moves to the mini PC via OCuLink external GPU over a direct PCIe connection. That's the next video. The dual GPU setup video and my guide on fitting models to your hardware are linked below. Thanks for watching.